Hello everyone, how are you doing? I'm doing good. Thank you very much for clicking into my video or my lesson. Welcome very much into this lesson whereby we are going to learn about probability, as you can see. So this is a probability form 3 and it's also learned in grade 9, the current CBC. So welcome very much. I'm teacher Purity Joel and we'll be learning together. So a bag contains 6 red counters and 4 blue counters. 2 counters are picked from the bag at random without replacement. A. Represent the events using a tree diagram. 1 mark. Then part B of the question, we are required to find the probability that the 2 counters picked are of the same color. So let us first solve part A of the question. Solution. And then, as you can see, the keyword in this question is using a tree diagram. We have other ways of solving probability, such as using an outcome table and so on. But in this case, we are strictly restricted to using a tree diagram. So we are supposed to know the total number of counters in that bag, which is 6, then which are red, then plus 4 blue counters. So we have a total of counters are 6 plus 4, which is 10. And then now we are picking them, and again in this case we are told at random without replacement. Mark the word without replacement. Without replacement means that once a counter has been picked, the number of the total counters in the bag reduces by 1 and it is not replaced. So drawing the tree diagram for this case, we'll have the first attempt or the first picking. We'll pick a red or a blue, and then we need to know the probability of picking a red. Remember, 6 are red, 4 are blue. So the probability of picking a red marble, a counter in this case, is the number of red counters, which is 6 over the total number of counters, 10. So 6 over 10, and then for blue is 4 over 10. So the probability of picking a red counter is 6 over 10, and then the probability of picking a blue counter is 4 over 10 for the first picking. So remember, we are told that 2 counters are picked from the bag at random. So the other attempt to pick the second counter will be red, blue, and you don't interchange. You make sure that if the first time you started with red, blue, you also start with red, blue for the second case. So remember, in the first case, a red marble is picked. So the number of red, why am I talking about marbles? We are used to marbles. In this question, it's about counters. So a red counter is picked for the first case. So the number of red counters is going to reduce by 1 and become 6 minus 1, which is 5. And again this is 5, and again the total number of counters will reduce by 1 to become 9. So now the probability of picking a red marble, a red counter in the second case, is 5/9. Now a blue one is not picked, so the blues remain to be 4. So this is 4/9 again, 4/9. So if you want to confirm whether your fractions or your probabilities are correct, the numerators added should add up to the denominator. That is, the probability of the two should add up to 1 because you can either pick a red or a blue. So it's 5/9 plus 4/9 is 1. 9/9, which is 1. The same case here. Again, 6/10 plus 4/10 is 10/10, which is also 1. So again here we have red, blue. So red is not picked here, so red remains to be 6. But remember that in the first case a counter was picked and there was no replacement, so out of 9. Now in this case we are picking blue and the blues were 4, so we are remaining with 3 out of 9. Yeah, so the outcomes will be picking a red and a red, or picking a red, I'm writing that from red, 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 blue, or picking a blue and a red, or picking a blue and a blue, a blue and a blue. It's always good to write the outcomes, the possible outcomes from the pickings. So that is it about part A of the question. We are just told to represent the event using a tree diagram. Yeah, it is very simple. That is why it is given 1 mark. You just need to note down the keywords without replacement, and again which color is being picked, and making sure that the fractions or the probabilities are written in the correct way. So from there we move to part B, finding the probability that the two counters picked have the same color. Same color means can either pick a red and a red or a blue and a blue. So we'll have part B. Yeah, this was part A. Part B will have probability of picking a red and a red, or probability of picking a blue and a blue. Then in probability we say that and means multiplication, where we use the conjunction and, we replace it with multiplication in mathematics, probability, and when we use or, we replace it with correct addition. Yeah, so this will be equal to, what is the probability of picking a red and a red? Come back to our tree diagram here. Red and red. So it is 6/10 and times red again 5/9 times 5/9. Then you enclose that in brackets, plus, because of or, a blue and a blue. So blue 4/10 times 3/9. So this is 4/10 plus 3 over 9. And that is supposed to give us 6 over 10 times 5 over 9, which is 1 over 3, then plus 4 over 10 plus 3 over 9, which is 2 out of 15. And this is 1 over 3 plus 2 over 15 is equal to 7 over 15. And that is the probability of picking two counters being of the same color, or the probability that the two counters picked are of the same color. Yeah, so that is it about that question. Very simple, but some students, I don't know what's up with probability to them. They end up getting it wrong, because remember, when you miss it at this point, then definitely you cannot get any mark, or you're going to miss part B. So from there, we move to the next question, question 2. It says, in a certain firm, there are 6 men and 4 women employees. 2 employees are chosen at random to attend a seminar. Determine the probability that a man and a woman are chosen. 3 marks. So, again, there's another case of without replacement. Even if it is not mentioned, once one gender is picked, it will not be replaced, because we are told that there are 6 men and 4 women. So, as you can see again here, the total is 6. The total of employees will be 6 plus 4, which is 10. Here. So, we want to know the probability of that a man and a woman are chosen. And again, now the keyword here is 2 employees. So we are going to pick twice, the first time and the second time, for us to get 2 employees. So let us represent this information in a tree diagram for us to come up with a solution. So we'll have probability of picking a man, probability of picking a woman, probability of picking a man. 6 are men, 4 are women. So we have men and then women. So the probability of picking a man or choosing a man will be 6 out of the total 10. Then probability of picking a woman is 4 out of 10. Then now the second time, you are going to pick a man or a woman. And remember, I said do not interchange. If you started with man, woman, continue in that order. Interchanging will bring out different solutions, outcomes. So, a man has already been picked. So, out of the 6 men, we are going to remain with 5, and then the total is 9, because 1 employee has already been picked. So, a woman has not been picked, has not been chosen. So, the women are still have 4. So we'll have 4 out of 9. You can try to add the two fractions, the two probabilities, to see whether you are getting 1. You're getting 1. 5 over 9 plus 4 over 9 is 9 over 9, which is 1. Then we come to this case, whereby we'll have a man and a woman. In this case, no man has been picked, so the men remain to be 6 out of 9. And then a woman has been picked, because this is a woman, then this is a woman. So we'll have 3 out of 9. Confirm whether adding the two probabilities will give you 1. Yes, that is 9 over 9, which is 1. So the outcomes are picking a man and a man, picking a man and a woman, picking a woman and a man, picking a woman and a woman. Yes, and the question is, determine the probability that a man and a woman are chosen. So a man and a woman means that this is not one of the probabilities, because this is a man and a man and a woman and a man, and then a woman and a woman. So the probabilities are 2. So you'll have the probability of picking, we'll have the probability of picking a man and a woman, or a woman and a man, which is given by, remember before or earlier I said that a multiplication, when we talk of and, the moment you mention and in probability, it means multiplication. The moment you mention or in probability, it means addition. So the probability of picking a man and a woman is 6 over 10 times 4 over 9. So 6 over 10 times 4 over 9, and close that in brackets, plus a woman and a man, 4 over 10 plus 6 over 9. So 4 over 10 plus 6 over 9. Yes. And then this is giving us 6 over 10. Oh, sorry, this is times because of and. Sorry for that. Yeah. So 6 over 10 times 4 over 9 is 4 over 15. Then plus 4 over 10 times 6 over 9 gives us again 4 over 15. Confirm that in your calculator. And this is supposed to give us 8 over 15. 8 out of 15. Anytime you are doing a question on probability, and then you are supposed to be sure that the fraction you are getting should be less than 1. There is no time probability will go beyond 1. The maximum probability is 1. The minimum probability is 0. In short, probability ranges between 0 to 1. Yes. And then some people ask, when is probability 0 and when is probability 1? Can give an example of probability being 0. Something that cannot happen. Uncertainty. For instance, what is the probability that you are older than your mother? Can you be older than your mother? No. So definitely the probability of any person being older than their mother is just 0. You can give other examples of probability being 0 in the comment section. Yeah. Then I can give one example of probability being 1. What is the probability that the sun will rise tomorrow? Very certain. We are very certain that the sun must rise tomorrow. Unless miracles happen or Jesus come back. Yeah, we are expecting the sun to rise tomorrow. So it is very certain that the sun will rise tomorrow very early in the morning. So when we are certain of an event, then the probability is 1. We are very sure it will happen. It is 1. Yeah, and other many examples, you can give them on the comment section. Let us interact. Okay, so that is it about that question. Yeah, very simple. You'll get your 3 marks. In the next class, stay tuned. We'll do questions worthy 10 marks on probability. Or do you need more questions on probability? Comment down there on the comment section. Yeah, so from there we move to the last question. Yeah, this is the last question on this class. Then you'll tell me whether you need more questions on probability, probably the 10 marks questions. Yeah, so that when you get them, the section B, you can just rush to the questions and solve them confidently. So a committee of 3 people was chosen at random from a group of 5 men and 6 women. Find the probability that the committee consisted of more men than women. Yeah. So let us solve the question together. We want to know the total number of people in this group of people. 5 men and then 6 women. So the total, let us solve solution. Total is always the first thing. Love 5 men plus 6 women. 5 men and 6 women. That is 11 people. And then the keyword again here is committee of 3 people. 3 people. So we need 3. We are going to pick 3 times. 3 times. So let us pick the first time. So 5 are men, 6 are women. So you can write that. So let us pick together the first time. And then you draw your tree diagram to be a bit spacious. Remember, we are going to pick 3 times in this case. So we can start with men, women. Men are 5 out of the total 11. Yeah, so what is the probability of choosing a man? Correct. 5 out of 11. And then a woman, 6 out of 11. And then the second time we are going to pick a man or a woman. And then we know that there is no replacement here. So the first time a man was picked, how many men remained? Yes, 4. Then the total people, 10. So 4 out of 10. Then remember that no woman was picked. So women remain 6 out of 10. The total people who remained. Then in this case, a man and a woman. So no woman is picked. No man is picked. So men are 4. Sorry, 5 in this second case. 5 out of 10. Then in the second case, a woman is picked, so the women were 6, so they are going to remain 5 out of 10. Sorry for my camera is not stable. Okay, so now we'll have 5 over 10 plus 5 over 10 is 10 over 10, so you are sure that your probabilities are very correct. So we move to the third picking. So the third picking, we are going to pick from the 4. So we'll have a man and a woman. So in this case, a man is picked. They were remaining 4. So we'll remain with 3 over the total now. By the time we are picking the third time, the people will be remaining how many? 9. Correct. So over 9. Then in this case, no woman is picked, so women are still 6 over 9. You can confirm whether your two probabilities are adding up to 1. Yes, 3 over 9 plus 6 over 9 is 9 over 9, which is 1. That is the best way of checking whether you are in the right track. Then now, in this case, we'll have a man and a woman. So, in this case, no man is picked. So, from the second case, the men were 4. So, out of 9. Don't say 5, because remember in the second case, a man was picked and they remained 4. So, that is why we are saying 4. And then in this case, a woman is now picked. So we have 5 out of 9. Confirm your two fractions. 4 over 9 plus 5 over 9, 9 over 9, which is 1. Then we move to this other case here, whereby we are going to pick a man and a woman. Man or a woman, sorry. Then a man is picked and the men were 5 before. The men were 5, so we'll remain with 4 out of 9. And then no woman is picked. The women were 6. Remember, in this case, women are still 6. So we'll have not 6, sorry. 5, because from this case a woman was picked. A woman was picked from the second case. So the women remained 5 out of 9. That is why I was telling you, confirming from the addition will also help you remember there is somewhere you are going wrong. Yeah, I cannot talk of 6 because in this case our man was picked, so they remained 5. So we'll have 5. Yes, let us proceed to the last one. A man and a woman. Yes, in this case no man is picked, but a man was picked from that point, so we have 4/9. And then in this case men are 5 from this. Remember, we have the uppercase and then the lowercase. So in this case no man is picked, so we'll have 5, sorry for that, 5 men because of these 5. Remember, they were 5. I don't know whether you are getting me. In this case they reduced to 4 because a man was picked here, but now here no man is picked because this is women, and they were remaining 5/10. But now in this case it will be over 9, so 5/9. And then lastly a woman is picked from the 5, we'll have 4/9. Then you can now confirm your fractions. 5/9 plus 4/9 is 9/9, and that is 1. Yeah, so if it could go the 4th time, the higher we go, yeah, the Gen Z say pressure increases. Yeah, so be very careful on the fractions. This is at this point you can really mess up. You just be very keen to see. Yeah, you can go back and listen the question from the start if you have not understood, or you can ask the comment section. So let us see the outcomes. In this case we'll have man. Committee can be of 3 men. From the probabilities can be a man, a woman, a man and a woman. It can be of a man, a woman and a man, a woman and a man. It can be of a man, a woman and a woman, woman and a woman. It can be of a woman, a man and a man, woman, a man and a man. It can be of a woman, a man and a woman, woman, a man and a woman. It can be of a where are we? A woman and a man, a woman and a man. It can be of a woman and a woman. How can this committee be? 3 women. Yeah, it can be really a good committee. Are you sure? Yeah. Okay, so let us go back to our question. Find the probability that the committee consisted of more men than women. So look at our outcomes, our possible outcomes. So more men than women means that we are supposed to see 2 men here, because remember the committee should have a total of 3. So whenever we have 2 M's, we need that probability. So this one out, this one in, this one man in, this one out, this one in, this one out, this one out. So we have three probabilities. So we are going to do that. We'll have the probability of the committee being of a man, woman, a man, and a man, and then a woman. Or the committee can be of a man, a woman, and a man. Don't interchange. A man, a woman, and a man. Sorry. Or it can be of woman, a man, and a man. Or woman, a man, and a man. Yeah, then now we go back to our tree diagram and substitute the probabilities. So we'll have being equal to probability of choosing a man, and a woman. Back here, a man, and a woman will be 5/11. Let me focus. 5/11 times 4/10 times 6/9. So we'll have 5/11 and or times 4/10 times 6/9 and close that, or plus sorry, a man, a woman, and a man. A man, a woman, and a man, which is 5/11 times 6/10 times 4/9. So 5/11 times 6/10 times 4/9 and close that, then plus the last one, which is a woman, a man, and a man. So woman, man, man. So 6/11 times 5/10 times 4/9. So 6/11 times 5/10 times 4/9. Then we enclose that. Yeah. So this is giving us 5/11 times 4/10 times 6/9 is supposed to give us 4/33. Then plus 5/11 times 6/10 times 4/9 is also 4/33. Sorry. Then plus 6/11 times 5/10 times 4/9, 4/33. And this is giving us 12/33. Yeah, can we leave our answer in that point? Yes? No. We give probabilities in the simplest form, or any fraction should be left in the simplest form. Yeah, you should know that. So simplifying this gives us 4/11, and that is the probability of the committee consisting of more men than women. 4/11. Yeah. So thank you very much for watching up to that point. If you are still here, you really mean a lot to me. Thank you. Welcome back to this channel. Watch more videos. Feel free to ask any question. If you have not yet subscribed, please, I know this lesson is helpful to you. And if you are truly finding it helpful, just click that subscribe button, follow this channel, and you will get more interesting lessons. So thank you very much for watching. Till next time, bye bye.